Hello, I'm your expert mechanical engineer specializing in Ram truck transmissions. Today, we're diving deep into the critical differences between two important 8-speed automatic transmissions used in Ram trucks. The 8HP45 and 845RE are both sophisticated 8-speed automatic transmissions, but they have important differences that every Ram truck owner should understand. These are not simple mechanical devices. Let me show you the incredible complexity inside a modern 8-speed automatic transmission. Each transmission contains hundreds of precisely engineered components working together: planetary gears, clutch packs, valve bodies, and control systems. Understanding the differences between these transmissions is crucial for Ram truck performance, reliability, and longevity. The choice between them can significantly impact your truck's service life. Throughout this analysis, we'll examine manufacturing differences, internal components, durability factors, and real-world performance to help you make informed decisions about your Ram truck's transmission. The valve body is one of the most critical components in any automatic transmission. It serves as the hydraulic control center that directs transmission fluid flow throughout the system. Here we see a physical valve body from a transmission. Notice the complex network of channels, ports, and solenoids with orange connectors. These solenoids control the flow of transmission fluid through various passages. This technical diagram reveals the complexity of valve body design. Each numbered point represents a specific control function. The ZF8HP55 transmission uses an entirely different valve body architecture compared to standard 8HP designs. This exploded view shows the individual components that make up a valve body assembly. Each valve, spring, and spacer must be precisely engineered to control fluid pressure and flow timing. Valve body variations have three primary effects on transmission operation. First, they control shift timing, determining exactly when the transmission changes gears. Second, they affect smoothness, how the shifts feel to the driver. Finally, they impact overall performance and efficiency of the transmission system. Because valve body designs vary between transmission models, each requires specific calibration and maintenance procedures. Understanding these differences is crucial for proper transmission service and optimal performance. One important difference between the 845RE and 8HP45 transmissions lies in their oil pan design. The 845RE may feature a deeper oil pan in certain applications, which provides several significant advantages. Here we can see examples of transmission oil pans and their relationship to the overall transmission assembly. The oil pan serves as the reservoir for transmission fluid and plays a crucial role in the system's operation. The key difference is in the depth. While the 8HP45 uses a standard depth oil pan, the 845RE in some applications features a deeper pan design. This increased depth allows for greater fluid capacity. The deeper pan can hold approximately 2 to 3 additional quarts of transmission fluid compared to the standard pan. This increased fluid capacity provides several important benefits for transmission operation and longevity. The deeper oil pan provides three key advantages. First, enhanced cooling capability. More transmission fluid means better heat dissipation, keeping operating temperatures lower during demanding conditions. Second, extended fluid life. The additional fluid volume reduces thermal stress on the transmission fluid, helping it maintain its protective properties longer and extending service intervals. Third, improved performance under heavy use conditions. This is especially beneficial for applications involving frequent towing, hauling heavy loads, or stop-and-go driving, where the transmission works harder and generates more heat. Under heavy use conditions, the deeper oil pan can result in significantly cooler operating temperatures. While a standard pan might see temperatures reach 220 degrees Fahrenheit, the deeper pan with its additional fluid capacity can operate 20 degrees cooler at around 200 degrees Fahrenheit. This temperature reduction is significant because transmission fluid begins to break down rapidly at high temperatures. Every 20-degree reduction in operating temperature can potentially double the life of the transmission fluid and reduce wear on internal components. The 8HP45 transmission has a specific torque capacity rating that determines its operational limits and reliability boundaries. The 8HP45 is engineered to handle torque inputs up to 450 Newton meters. This specification represents the maximum rotational force the transmission can reliably process without compromising its internal components. Operating within the safe zone, up to 450 Newton meters, ensures optimal transmission longevity. The green zone represents the engineered safety margin where all components function as designed. Exceeding this torque limit pushes the transmission into the danger zone, where internal components experience stress beyond their design parameters, leading to accelerated wear and potential failure. The transmission's internal components are precisely engineered to handle specific load requirements. Let's examine the technical specifications that define these limits. This technical diagram shows the precise fastener tightening specifications required for the 8HP transmission. Each bolt and component has specific torque requirements that must be met during assembly and maintenance. The precision engineering extends to every component within the transmission. Critical parts like clutch assemblies and planetary gear sets must operate within exact tolerances. This precision-machined component represents the level of engineering that goes into every transmission part. When torque limits are exceeded, these carefully designed components experience stress that can lead to premature wear, seal degradation, and ultimately, transmission failure. The 450 Newton-meter torque rating is not just a number. It represents the engineering boundary that ensures your 8HP45 transmission operates reliably for years to come. Respecting this limit is essential for maintaining transmission health and avoiding costly repairs. Chrysler doesn't simply copy the ZF design. Instead, they actively adapt and improve the 845RE transmission based on real-world feedback from millions of vehicles on the road. The process begins with real-world vehicles collecting performance data. This data flows back to Chrysler's engineering teams, who analyze it to identify areas for improvement. This feedback loop has led to specific component improvements in the 845RE. Let's examine one key example: the clutch pack modifications. Based on real-world performance data, Chrysler discovered that adding an extra pair of separator and friction plates to certain clutch packs significantly improved durability and performance. These real-world adaptations provide several key benefits: enhanced durability under stress, improved performance in specific applications, reduced warranty claims, and ultimately better customer satisfaction. This collaborative approach between Chrysler and ZF creates a continuous improvement cycle. Field experience directly informs engineering decisions, leading to more reliable transmissions. This continuous improvement approach ensures that the 845RE transmission evolves and adapts to meet the real-world demands of Ram truck owners, potentially offering enhanced reliability in scenarios where the original design might face challenges. Ram 1500 transmissions, whether 8HP45 or 845RE, can experience several common issues that affect their performance and reliability. Understanding these problems helps identify when professional service is needed. The three most commonly reported issues are hard shifting, transmission slipping, and unexpected shifting into neutral. Each of these symptoms indicates different underlying problems within the transmission system. Hard shifting manifests as harsh engagement when changing gears, delayed response to shift commands, audible clunking sounds, and vehicle jerking during acceleration. These symptoms often worsen over time if left unaddressed. Transmission slipping occurs when the engine RPM rises, but the vehicle doesn't accelerate proportionally. This creates a loss of power, often accompanied by a burning smell from overheated transmission fluid and difficulty maintaining consistent speeds. The Transmission Control Module, or TCM, is the electronic brain that controls shift timing and hydraulic pressure. When the TCM malfunctions, it can cause faulty shift timing, incorrect pressure control, communication errors with other vehicle systems, and sensor misreadings that lead to the symptoms we've discussed. The valve body contains numerous precision-machined valves, springs, and passages that direct hydraulic fluid to control gear changes. Over time, these components can wear, stick, or become contaminated, leading to erratic shifting behavior and the problems we've identified. Accumulators smooth out pressure spikes during gear changes by absorbing and releasing hydraulic fluid. When accumulator pistons wear, springs weaken, or seals deteriorate, the result is harsh shifting and poor shift quality that drivers immediately notice. When experiencing any of these transmission issues, professional diagnosis is essential. These symptoms can have multiple underlying causes, and early intervention prevents more costly repairs. Proper diagnostic equipment can identify whether the problem lies with the TCM, valve body, or other transmission components. The Transmission Control Module, or TCM, serves as the brain of your transmission system. This sophisticated computer continuously monitors, processes, and controls every aspect of transmission operation. The TCM receives critical data from multiple sensors throughout the vehicle. These sensors monitor vehicle speed, throttle position, engine RPM, transmission fluid temperature, and output shaft speed. All sensor data flows continuously into the TCM, where sophisticated algorithms process this information in real time to determine optimal transmission behavior. Based on this processed data, the TCM sends precise control signals to various transmission components including shift solenoids, clutch controls, torque converter lockup, and line pressure regulation. These control signals ensure smooth shifting, optimal clutch engagement timing, and efficient power transfer throughout the transmission system. When the TCM malfunctions, the entire transmission system becomes compromised. A faulty TCM cannot properly process sensor data or send accurate control signals. Common symptoms of TCM malfunction include erratic shifting patterns, harsh or delayed shifts, transmission slipping, reduced fuel economy, and activation of the check engine light. Proper diagnosis of TCM problems requires specialized diagnostic equipment. OBD scanners can read diagnostic trouble codes stored in the TCM's memory to identify specific malfunctions. Diagnostic trouble codes such as P0700, P715, P720, and P0731 can indicate various TCM-related issues, from general transmission control problems to specific sensor failures. Depending on the diagnosis, TCM issues may be resolved through software reprogramming to update control algorithms, or in severe cases, complete TCM replacement may be necessary to restore proper transmission function. Professional diagnosis and repair of TCM issues are essential for maintaining optimal transmission performance, preventing further damage, and ensuring the longevity of your transmission system. From a mechanical engineering perspective, both the 8HP45 and 845RE transmissions represent robust, well-engineered designs that demonstrate solid automotive engineering principles. These technical diagrams illustrate the sophisticated engineering behind both transmissions. The detailed specifications and complex internal components demonstrate the level of precision engineering that goes into modern automatic transmissions. Both designs feature robust construction with high-quality materials, precise manufacturing tolerances, and proven mechanical systems. The engineering fundamentals are sound in both cases. However, and this is a critical point that cannot be overstated, the actual longevity and reliability of either transmission depends far more on external factors than on the inherent design differences between them. The two most critical factors determining transmission longevity are proper maintenance and responsible usage patterns. Regular fluid changes, following manufacturer specifications, and avoiding excessive stress through aggressive driving or overloading are far more important than the subtle engineering differences between these two transmissions. As an engineer, I would emphasize that while both transmissions are well designed, the owner's commitment to proper care and operation will ultimately determine which transmission lasts longer in any given application. Transmission fluid is truly the lifeblood of your transmission. It lubricates moving parts, transfers power, and keeps everything running smoothly. Without proper fluid maintenance, even the best transmission will fail prematurely. The condition of your transmission fluid tells you everything about its health. Fresh fluid should be light pink or red in color. As it ages and breaks down, it becomes darker. Dark brown fluid needs attention, while black or burnt-smelling fluid indicates serious problems. Regular inspection of your transmission fluid is simple but crucial. With the engine warm and vehicle on level ground, Check both the fluid level and condition. Look for proper color, smell for any burnt odor, and watch for metal particles that indicate internal wear. Using the correct fluid specification is absolutely critical. Each transmission is designed for specific fluid properties. Using the wrong fluid can damage seals, cause poor shifting, accelerate wear, and even lead to complete transmission failure. Always consult your owner's manual. For both the 8HP45 and 845RE transmissions, ZF recommends changing the fluid every 50,000 to 75,000 miles or every 8 years. This schedule prevents fluid degradation and maintains optimal performance throughout the transmission's life. Remember, regular fluid changes are the single most important factor in transmission longevity. Don't wait until problems appear. Preventive maintenance is always less expensive than repairs. Your transmission will reward you with years of reliable service when properly maintained. Transmission longevity depends heavily on how you treat your vehicle. Avoiding excessive stress through proper driving habits and towing practices can significantly extend your transmission's lifespan. Heavy towing places enormous stress on your transmission. The image shows what can happen when towing exceeds the vehicle's capacity: overheating, excessive wear, and potential failure. Heavy towing generates excessive heat, increases torque demands, forces constant high-load operation, and accelerates wear on internal clutches and bands. Aggressive driving behaviors create unnecessary stress on transmission components. These habits force the transmission to work harder than designed, leading to premature wear and potential failure. Hard acceleration and braking, rapid gear changes under load, high RPM operation, and resulting transmission overheating all contribute to reduced transmission lifespan. This cutaway view shows the complex internal components that suffer when transmissions are stressed. Each component has limits, and exceeding them leads to accelerated wear and eventual failure. Clutch packs wear from excessive heat, planetary gears suffer under extreme loads, valve bodies experience pressure spikes, and torque converters face increased stress during aggressive operation. Treating your transmission with respect involves following these key practices: gradual acceleration, staying within towing capacity, allowing warm-up time, ensuring smooth gear transitions, monitoring temperature, and maintaining regular service schedules. When you treat your transmission with respect through proper driving habits and maintenance, it will reward you with years of reliable service, avoiding costly repairs and replacements. The transmission landscape is rapidly evolving. Ram trucks and the entire automotive industry are moving toward greater automation, advanced control systems, and electrification integration. Current transmissions like the 8HP45 and 845RE represent solid engineering, but future transmissions will feature more gears, artificial intelligence control, electrified components, and seamless integration with vehicle systems. Let's examine the key trends driving this transformation, starting with automation advancement. Automation in transmissions has evolved from basic automatic shifting to intelligent systems that adapt to driving conditions. Future AI-controlled transmissions will predict optimal shift patterns and integrate with autonomous driving systems. Now, let's explore electrification, the most significant trend reshaping transmission technology. Electric drive modules represent the future of transmission technology. These integrated units combine electric motors with traditional transmissions, enabling hybrid and electric vehicle operation while maintaining the performance Ram truck owners expect. Beyond electrification, future transmissions will integrate with numerous advanced technologies. Modern transmissions are becoming increasingly complex, integrating with fleet management systems, providing predictive maintenance capabilities, and supporting autonomous driving functions. This complexity requires advanced control systems and connectivity. The future transmission landscape will be defined by intelligent adaptation and seamless integration. These trends will transform Ram trucks and the entire automotive industry. More gears will optimize efficiency, AI will provide intelligent control, electrification will enable new powertrains, and connectivity will revolutionize how we interact with our vehicles. The future of transmissions is not just about shifting gears, but but about intelligent, integrated systems that enhance every aspect of the driving experience. Modern automatic transmissions like the 8HP series are no longer standalone components. They're becoming integral parts of sophisticated automotive technology ecosystems, connecting with autonomous driving systems and fleet management platforms. The complex internal architecture of the 8HP transmission includes sophisticated electronic control systems that can communicate with external technologies. Multiple sensors and control modules enable real-time data exchange. The transmission control module serves as the central hub, receiving and processing data from autonomous driving systems and fleet management platforms. This integration enables optimized shift patterns and performance adjustments. Data flows continuously between these systems. Autonomous driving systems provide speed and route information, while fleet management systems monitor performance metrics. The transmission responds with optimized control strategies. Let's examine how this integration works in practice with fleet management systems. Fleet management dashboards like this one collect real-time transmission data from entire vehicle fleets. This includes fuel efficiency metrics, maintenance schedules, and performance analytics that help optimize operations. This integration provides multiple benefits. Real-time fuel efficiency monitoring helps reduce operating costs, predictive maintenance prevents unexpected breakdowns, route optimization improves delivery times, and driver behavior analysis enables better training programs. The quantifiable benefits of this technology integration are significant. Fleet operators report fuel efficiency improvements of up to 15%, maintenance optimization gains of 25%, and overall performance increases of 18%. The integration of 8HP series transmissions with new technologies represents a fundamental shift in automotive engineering. These smart transmissions don't just shift gears, they actively participate in optimizing vehicle performance, reducing costs, and improving safety across entire fleets. The ZF 8HP transmission family represents forward-thinking engineering, designed from the ground up to be compatible with hybrid powertrains. This compatibility ensures these transmissions remain relevant as the automotive industry transitions toward electrification. The 8HP family supports 3 distinct hybrid configurations. Mild hybrid systems use a 48-volt electrical system to assist the engine during acceleration, improving fuel efficiency without major powertrain changes. Full hybrid systems can operate on electric power alone at low speeds, seamlessly switching between electric and gasoline power as needed for optimal efficiency. Plug-in hybrid systems feature large battery packs that can be recharged from external power sources, providing extended electric-only driving range for daily commuting. Modern hybrid vehicles integrate multiple electrical systems that work seamlessly with the 8HP transmission. The high-voltage battery, motor generator, and electronic control units all communicate with the transmission control module. This hybrid compatibility provides several key advantages for Ram truck owners and the automotive industry as a whole. The 8HP family's hybrid compatibility offers future-proof design that ensures transmission longevity, seamless integration with electric motors, consistent performance across different power sources, and full support for the industry's transition to electrification. The internal design of the 8HP transmission includes specific integration points that accommodate hybrid system components, ensuring smooth power delivery whether operating in electric, gasoline, or combined modes. This hybrid compatibility represents more than just technical capability. It's a strategic advantage that ensures the 8HP transmission family remains relevant and valuable as Ram trucks and the entire automotive industry continue their transition toward electrification. After examining both transmissions in detail, we can draw some important conclusions about the 8H45 and 8845RE transmissions used in Ram trucks. Both the 8HP45 and 845RE are fundamentally capable transmissions. While the ZF-built 8HP45 might have a slight edge in initial build quality due to ZF's extensive transmission expertise, the Chrysler-built 845RE benefits from real-world adaptations and improvements based on actual field experience. However, the most important factor determining transmission longevity isn't which brand built it, but rather how well it's maintained and how responsibly it's driven. These two factors have far more impact on transmission life than the subtle differences between the 8H45 and 845RE. Proper maintenance includes regular fluid changes with the correct transmission fluid, following manufacturer service intervals, and addressing any issues promptly. The transmission fluid is truly the lifeblood of these complex systems. Responsible driving means avoiding aggressive acceleration and braking, using proper towing techniques when hauling heavy loads, and allowing the transmission to warm up properly in cold weather. These habits significantly extend transmission life, regardless of which version you have. The bottom line is this: whether you have an 8HP45 or 845R in your Ram truck, your maintenance habits and driving style will determine how long it lasts. Take care of your transmission with regular maintenance and responsible driving, and either version will provide years of reliable service.